Hey Algebra 2 class, we are now doing part 2 of the notes for 4.1. So this is just a continuation. We're not graphing too much this time, but if you read that first paragraph, take a second and read it, pause it, and you can see where all the variables should go in that formula. Alright, one thing that I highlighted is we are using percentages as decimals, so 25% would be 0.25. So move over your decimal 2 places to the left, and that gives you a percent. Alright, this first one, the initial amount is 527. The growth factor is 1.39. And since that growth factor is 1 plus the percent as a decimal, that means that percent must have been 0.39, which is 39%. And number 2, in 1996, there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by about 92% each year. So the numbers that are important are 2,573, which is my initial amount, and then the percent increase is 0.92. So I'm just filling in that original formula that was bold up above number 1. Alright, and I'm just 1 plus 0.92, I combine that to be 1.92. Alright, now, how many incidents were there in 2003? Well, T is the years after 1996. So that means 2003 is 7 years after 1996. So I put a 7 in for T. So you don't put 2003 right there. That would give you a totally different number. It's years since 1996. Alright, so plug that into your calculator. 2,573 times 1.92 to the power of 7. Once you plug that in, you should get 247,485 incidents. Alright, now we're going to graph this, but we're not going to graph it like we were last time on graphs. We are going to use a graphing calculator. So press Y equals, and you're going to plug in 2,573 times 1.92 to the power of x in your Y equals. Alright, then press second graph, which is the table, and it should give you a bunch of values for x and for y. Alright, just writing out instructions. You might want to write these too for when you're doing your homework. You press second graph to get to table. You have a bunch of values for x and y. Now y is the number of incidents. X is the number of years. And so I'm looking for when y equals near 125,000. So when I scroll down on that table, I end up seeing that y is 128,000 when x is 6. So 6 years after 1996 would be 2002. Alright, we'll have more practice with those in case that one didn't make sense. Alright, in 1970, the population of Kern County, California, where Bakersfield is located, was about 330,000. Right, that's my initial population. It grew at an average annual rate of 2.4%, so 1 plus 0.024, and then to the power of T, where T is years after 1970. How many people lived there in 1990? I'm just copying that formula I came up with. I'm going to replace T with 20 because 1990 is 20 years after 1970. Right, plug that into your calculator. And you find the population is about 530,290 people. Alright, we're going to plug this one into the calculator as well. So into y equals, you should plug in 330,000 times 1.024 to the power of x. X again is y again is population, and x is years. Alright, I want to know when y is close to 400,000. When I scroll pressing second graph to get to the table, I find that y is really close to 400,000. I don't know what I said earlier. I think I said 40. Whoops. At x equals 8. So that would be 8 years after 1970, which is 1978. Alright, this is a different way of doing the formula, but it's very similar. It's compound interest. So you have your principal, P, which is what you deposit. The rate is R, compounded in times a year, and the most common thing people miss is that N is in two different spots. T is still years, and now we use the letter A to be the amount in the account. Alright, so I am depositing $4,000 into an account. It pays 0.0292% annual interest. And it is being compounded quarterly, so that means that N is going to be 4, since it's 4 times per year. Right, and then that N number 4 also goes up in the power times 1, because we're looking after 1 year. Alright, plugging this into your calculator is kind of tricky. You have to use a lot of parentheses. So I end up writing, after I give you the answer, so $4,118 and about 9 cents is what you would get after a year in interest. But I am going to write in just a second what you should input into your calculator to get that answer. And you really should be practicing while I'm doing these notes like you would in class, just to make sure that you're getting the same answers I am. So you need to input it just how I write it here. So 4,000, parentheses, 1 plus, new parentheses, 0.0292 divided by 4, close parentheses, close other parentheses, and then raised to the power of 4. Alright, daily. So this is the same problem. I'm depositing $4,000. I still have that rate of 0.0292. Now daily would be 365, unless it's a leap year, but we won't count that. Alright, so you should have this formula, and again, input very carefully into your calculator. 4,000 times 1 plus parentheses 0.0292 divided by 365, close parentheses, to the power of 365. I know it's a lot, but y'all can do it. Alright, so you'd make a little more money, about 40 cents more, if you did it compounding daily. Alright, this one, you're depositing $2,000 into an account that pays 0.04, and it's compounded daily again, so over 365 to the power of 365 times 3. So in the past, in the last problem, it was just 1 year. Now it's 3 years. Alright, this one, you also have to be careful in your calculator, because the power also needs to be in separate parentheses, or else you will get a totally different answer. I did it incorrectly the first time and ended up with like $6,000 and some dollars. So you should not get that answer if you input it with the extra parentheses. Alright, last one, and then I do a homework problem as well, so stay tuned for that, because you need to know how to do that one for your homework, and it gives you a free answer. Alright, depositing $5,500 at a rate of 0.036, and then it's compounded monthly, 12 months in a year, so it's 12 for your letter N. Alright, again, I'm writing how to do this in your calculator, how to enter it. And if you enter it this way, you should get the same answer that I do. So plug that on in, and you end up with the amount after 2 years. It's $5,909.97. Alrighty, this is number 8 on your homework. you want to have $3,000 in your savings account after 3 years. So you're not depositing $3,000, you want $3,000. So that is actually your A this time, and we have to solve for P. Alright, you'll notice in letter B, if you look at that formula, I did it incorrectly. I'll change it at the end. But anyways, so that should be the formula you have, and this time we're looking for P. So I'm going to go ahead and figure out in my calculator what all that stuff in parentheses raised to the power is, so that I can divide by it on both sides and get P by itself. Right, so when you enter that in your calculator, you should end up with 1.0696 and then a bunch of other decimals. So divide by that long number on both sides. I'm just going to erase this so I have room. Right, and then you should get P, what you should deposit, should be about $2,804.71. Alright, again, I put 4 for my years in B and C, and it should have been 3, so I erase it and change it. Make sure you didn't copy that down wrong. Y'all do great. Email me with questions.